Thank you. Good afternoon, everyone, and thank you very much for joining this webinar. Well-being is a very popular concept these days, but have you considered the impact that buildings have on your well-being? And this is what we're going to investigate today. We're going to begin by talking about what is understood for well-being, and then we're going to focus on buildings and how they can affect our well-being, which is also known as indoor environmental quality. And finally, we're going to see the 5 main components of indoor environmental quality and how can they affect our well-being. Well-being looks at many aspects of life. Well-being is normally categorized in 4 groups. Physical, which includes aspects such as health or autonomy, mental health, social, which looks at human interaction, work well-being, which measures job satisfaction, work-life balance, work conditions, etc. Just to start with some figures, sickness costs the British economy around 15 billion per year, and only mental ill health costs companies, if we think about a company of 1,000 employees, it costs companies $1 million a year. So you can see that there is an advantage in trying to identify problems early. From a construction point of view, well-being translates into creating buildings that provide the right environment for ensuring the well-being of its occupants. When we take into account people, building, and the environment inside the building, then we are talking about indoor environmental quality. IEQ, or well-being, should be in our minds at all the stages of a building, from design stage to construction to the maintenance stage of a building. Although it's hard to quantify the economic impact for employees, it is easy to establish that the quality of a building can have a huge impact on the health and well-being of occupants. Now, when it comes to indoor environmental quality, we're talking about 5 main components, which are thermal comfort, light, indoor air quality, and others, which also tend to go together, and sound comfort. Let's start with light. Just as a brief reminder, when we have a source of light, the amount of light that it produces is measured in lumens, and this is called the luminous flux. The amount of lumens that hit a surface is called the illuminance, and what we normally measure, illuminance is what we normally measure in a building, or what is normally in a building contract. And finally, the luminance is the amount of light that reaches a person. Luminance sometimes is called brightness, and it measures the light that leaves a surface in a particular direction and considers the illuminance on the surface and the reflectance of the surface. The human eye does not see illuminance, it sees luminance, and therefore the amount of light delivered into space and the reflectance on the surfaces affects our ability to see. Now in this table we can see some lux levels and what they might be used for. In an office environment we normally tend to provide 500 lux, which are enough to be able to see our computer or to read from our computer, to read from a book. So we wouldn't need to provide an illuminance of 1,000 lux, for example, in every workplace. But perhaps we can consider a higher level of illuminance in different places in the building that are going to be used for a different purpose, for example, a drawing office. And we would need to think about this at design stage, so sooner rather than later. Now, we all know what happens when we have to work with poor light. We might get headaches, we get irritable, and we cannot concentrate on the task that we're doing. So how does this affect our performance? Now, it's not only important to provide the right amount of lux, the right amount of illuminance. Good lighting with lack of glare, for example, are indispensable for occupants to be productive. Some studies have also linked daylight windows and views to increase levels of productivity. And we can also use light to our advantage, knowing that some types of light, such as blue light, makes us more alert, and dim lights can make us more creative. Now, the next component of indoor environmental quality that we're going to talk about is sound comfort. I'm not going to talk in depth about sound, as my colleague Rebecca Hogg is already giving a presentation about sound on the 1st of March, which you can find online. And she is our acoustic expert. But very briefly, we can define sound as any air pressure variation that the human ear can detect, and noise as any unwanted sound. Now, designing for the right noise levels can reduce the satisfaction of the employees. High noise levels and vibration will result in a really uncomfortable environment. It can also cause hearing damage or stress, and it can affect our motivation, and it can also be very distracting. On the other hand, very low noise levels, for example in an office, they have effect on our speech privacy. In fact, in an office environment, we are not normally subjected to very high noise levels. But what distracts us is the fact that we can hear and understand other people's conversations, whether we want to or not. And actually, the ISO standard 3382 defines two acoustic parameters, which are defined as distances. The first one is the privacy distance, which is the distance in which a conversation cannot be longer understood. And the second one is the distraction distance, which is the distance where speech is only intelligible, but just a little, but it mostly contributes to the background noise. Now, the next point that I'm going to talk about is thermal comfort. Thermal comfort does not only consist of measuring temperature and humidity levels and ensuring that they are in the adequate range of values. There are several standards, for example, in America, ASHRAE 55 is quite popular for measuring thermal comfort. But in the UK, BSEN ISO 7730 is the one that we normally use. And the other standard, 7726, refers to the instrumentation that we use for measuring thermal comfort. For the measurements that we have to take for measuring thermal comfort, as I said before, they are not only temperature and humidity, but we also have to measure airspeed, turbulence intensity, and either black globe temperature or operative temperature. Here you can see some equipment that Visra uses for measuring thermal comfort. So here, for example, you have an anemometer, which measures the airspeed and also air temperature. Here you have a black globe, and here you have a humidity sensor. Now, the standard takes into account all these parameters that we have measured, but it also takes into account the clothing levels and the metabolic rate. So the clothing levels that we have will be different, depending on the layers of clothes that we have. And the metabolic rate refers to the activity that we are doing. So for example, if we are designing a space for a gym, people there will probably be running or exercising, and their metabolic rate will be higher. So we have to take this into account. And then with these three factors, we can calculate the draft risk, which is a percentage. It gives you the percentage of people that are going to be bothered by draft. The predicted mean vote predicts and the predicted percentage of dissatisfied, I'm going to explain to you in the next slide. If we did a survey of a particular environment, and we ask people to vote, are you very cold? And if you're very cold, vote -3. If you're comfortable with your environment, vote 0. And if you're slightly warm, more warm, and very, very warm, vote 1, 2, or 3. This would be a relationship. So if we had an environment in which people voted that they're very cold or very warm, the predicted percentage of dissatisfied people will be 100%. Now, if you see this graph, you will see that the predicted percentage of dissatisfied is never zero. There is always someone who is going to be uncomfortable with any environment. Annex A of the standard 7730 that I mentioned before categorizes the buildings or the spaces depending on the results of the predicted percentage of dissatisfied people, the predicted mean vote, and the draft risk, as you can see there. For example, here you can see some measurements that we took in a mock-up. We took speed, temperature, and then we calculated humidity levels, black globe temperature, and then we plotted speed and temperature because those were of interest, and then predicted mean vote and predicted percentage of dissatisfied. And as you see here, the predicted mean vote is very good. People with this particular design that we were testing would feel very comfortable with the environment, because if you see here, the results are mostly green and a bit yellow, and that corresponds to 0 and 0.5 PMV. For a second test, for a different test, we increased the heat load that we had close to the window just to see what would happen. We increased the solar component, and as you can see, the PMV, it showed that for that particular test scenario, the PMV in this area raised. So in the final build, this area was not occupied because it was decided that this area was not going to be occupied by people, because they would feel very, very warm. The next point that I'm going to talk about are indoor air quality and odours, for the reason that most of the time they are related to each other. Now, to have good indoor air quality, we would need first to define it, and I found this definition from CIPSI that I like very much, which is air with no known contaminants or harmful concentrations. This means that the air that we breathe in is going to have some contaminants, but we have to define good indoor air quality as the air that has contaminants, but they will not be harmful for you. Now, to have good indoor environmental quality, we have to have a few requirements. First of all, that if we get fresh air from outside, it's actually fresh, and we haven't got high pollution outside. We have also to have low emissions from internal sources. For example, from wall panels, from carpets, from glues, from paints, from the photocopier machine, which sometimes produce ozone, for example. And we have to have a good level of ventilation to dilute and remove these pollutants. Now, as I mentioned before, the ventilation role in space is to provide fresh air to the occupants of the space, to remove or dilute pollutants, and to remove odors and heat loads. But it's also very important to have good ventilation to control the humidity. Because this is not a presentation about indoor air quality, I'm going to summarize what are the main contaminants of indoor air pollution. And if anyone is interested, I can give more information later. But basically, we have 5. We have odors, we have VOCs, we have mold, particulates, and gases. Now, particulates are normally released are very fine dust particles that some of them can be external. They can come from traffic, from tobacco. They can come from the atmosphere, because sometimes even in the UK we get, for example, dust from the Sahara Desert. And they can cause a series of problems to people. From lung irritation to asthma or rhinitis. Now, with particles and with all of the other respiratory contaminants, what occurs is that the smaller they are, the deeper they can go into our lungs, and some contaminants, some gaseous contaminants, they can even get into our bloodstream. When it comes to gaseous pollutants, we have a very large range of gaseous pollutants that we're not going to go into in this presentation, but and therefore they can cause a series of trouble in your health. For example, CO2 can cause dizziness at very high levels. At extremely high levels, it can cause death, but we're talking about maybe 10,000 ppm. CO, which is carbon monoxide, on the other hand, it can kill you at very low concentrations. At maybe we're talking about 30 ppm, because when we breathe it in, it binds with the blood hemoglobin, creating a substance that is called carboxyhemoglobin, that doesn't let the blood transport oxygen into the cells and doesn't let the blood get rid of CO2 from the cells. We have other contaminants that occur naturally. For example, radon. Radon occurs naturally, and it can be found in rocks, and it's radioactive, so it can increase the risk of lung cancer, for example. Then we have volatile organic compounds that are carbon-based chemicals that can evaporate at room temperature, and we see them all the time. For example, we see them in cleaning products, in bleach, in paints, in carpets, in glues, for example, when we might paint our nails or remove it. And the effects on health are very varied depending on the contaminant and depending on the concentration. Some of them are possible carcinogens. For example, tetrachloroethylene, which was a product that was used in dry cleaners, and therefore it has been forbidden. And whereas others can just be a bit irritant to your breathing system. The next contaminant I'm going to talk about briefly is mold. Now, mold produces spores that float in the air, land on surfaces, and grow. And it can cause from sneezing to asthma attacks. And normally we have mold in buildings, and especially in homes, because of showering, because of breathing as well, washing, cooking, and the key to keep it under control is to have ventilation. Finally, I mentioned that I was going to talk about odours and indoor air quality together, and it's mostly because these two aspects go hand in hand. It is very difficult to quantify odours, sometimes because humans get used to their environment, and it's mostly when we walk into a space that we notice any smells, not when we have been there for a while. But Fanger quantified odor emissions, and he defined the OLF, which is the rate at which a normal adult who is wearing deodorant but no perfume and has had a shower emits air pollutants. And he also defined a decibel, which is if we put this person that is emitting 1 OLF of pollutants in a space that is ventilated, it's how would the air quality in this space be perceived. And he also established a relationship between the percentage of dissatisfaction and the number of OLFs. This table is just as an example of some OLF levels that Fanger defined. So what can be done with odours and what can be done with indoor air quality to improve it? Well, the first thing that we should think about is that we have good fresh air rates in the building. And then most contaminants can be diluted to levels that are not harmful for the occupants. Just know that I'm talking about fresh air. So for example, if we live in a very contaminated city, it would be a good idea to have a good air handling unit with filters that we change regularly so that we are actually providing fresh air and not external air to occupants. We should also design for the right levels of fresh air per person that is going to occupy the building, which at the moment is 10 liters per second. But inside a building, we can reduce the sources of emissions. We can use painting materials that do not emit a high level of VOCs. We can use carpet glues that also don't emit a high level of VOCs. And if we try to control the sources of emissions, we will have a better indoor air quality. Now, these are the aspects that I have talked about: thermal comfort, light, sound, indoor air quality, and odours. But in addition to these 5 aspects in buildings, some authors and some well-building standards also take into account other aspects. For example, water. Water quality refers to the characteristics of water intended for human consumption, and the quality of water at any point should be complied with. Should be compliant with the European Directive 98/83, which deals with drinking water. Other aspects that are taken into account are, for example, location, amenities, the views that the building has, the biophilia, or the love for the trees and nature, and some standards also consider nutrition or providing good healthy food to employees, and also the aesthetics. Also the aesthetics, the interior layout and the look of the internal office space and furnishings. Now, on this point, as you may know, Bistria is expanding north, and we're opening our new offices and laboratories very soon near Preston. And this was my suggestion for the interior design of the offices, and I do hope they go ahead with it. Now, on a more serious note, this interior layout is very effective for this company because the people in it need to be very creative, and no doubt the interior design of their offices is contributing to this. Finally, to sum up this presentation, I would like to say that what we have seen today is that well-being is made up of 4 elements: mental and physical health, social well-being, and work well-being. We have illustrated how buildings can affect our well-being. And finally, we have demonstrated that indoor environmental quality can improve the productivity, concentration, and the creativity of people. So to conclude, I would like you to think about the benefits that indoor environmental quality can bring to your workplaces and homes. Thank you very much. If you have any questions, please let me know.